Welcome to another episode of Code for Thought ByteSized RSE, sponsored by the Universe HPC program. The question that's occupying the minds of many of us at the moment is, what will work look like in future? And specifically for those of us in research who write code, how are we going to create apps and programs in the coming years? Because for sure, the need for having computer programs to help us with scientific discoveries isn't going away anytime soon. Well, maybe the future of working with computers will be like this.
Computer, generate a cross-section image of the dilithium crystal chamber. What about reorienting the crystal?
It is possible to reorient the crystal.
Yes, the heady days when the television series Star Trek The Next Generation filled our screens. But let's leave science fiction behind us for a minute and go back to planet Earth. And there's been a lot of talk about how generative AI solutions will change the way we live and work. For software engineers, a number of tools have become available that claim to make us more productive and write better code, all with the help of large language models like ChatGPT. And so this episode of ByteSized RSE is about AI-assisted coding. And to help me with that, I invited Liam Gao from the Imperial College, who's been using AI-assisted coding for writing software and teaching others, as you'll hear later. But before I go into the subject, I'd like to say a few words about ByteSized RSE. Some of you may already know what it is, but if you don't, ByteSized RSE is a concept that started in 2022 with a series of 8 online courses and corresponding companion podcast episodes on Code for Thought. The ByteSized RSE sessions are meant to be short, 1 hour long typically, and focus on practical exercises for a given technology, like for instance Git version control or some software development practices. The companion podcast episodes in return give additional background info and insight from people with experiences in the subject or field. ByteSized RSE has been a part of the Universe HPC program in the UK, a program that tried to find ways how we can train up researchers and research software engineers to work on large-scale computers and help bridge the skills gap. The Universe HPC program is now coming to an end, and with it the ByteSized RSE sessions. And so this will be the last ByteSized RSE themed episode on Code for Thought. And what better way to finish the third round of ByteSized RSE sessions with a theme about AI and how it will shape the future of programming, or not. So let's get started. Writing code is a bit of a strange thing, isn't it? We call Python, C++, Fortran, Rust, Julia, JavaScript and all the others languages. But writing code is not like writing an email, obviously. The rules for writing code are very restricted and limited, much more so than in natural languages. And for a good reason. In order for computers to understand our instructions, these instructions must be precise. No fussiness there. Where am I going with this, you wonder? Well, having to deal with specific syntax and rules in how you write code means it's easy to get it wrong, isn't it? A semicolon you forget, a curly bracket put in the wrong place, or simply a variable that has a typo in it. It happens to all and the best of us. And so efforts in helping us write programs with the correct syntax in whatever programming language you're using, and perhaps also help us write better code, is probably as old as writing software itself. To understand where AI-assisted coding fits in with all of this, I think it's worthwhile going back in time and look at least at some of the tools that have been developed. Tools that are still being used and I suspect will continue to be used for some time. It probably all started with syntax checking in general, that is, syntax checking of natural languages. In 1971, an engineer called Ralph Godin wrote a program called iSpell that worked on the spelling of some European languages. This was ported to, for instance, the Unix operating system, where a variation of the program still exists, I believe. But checking the spelling of a word is probably not enough when it comes to coding. In the early years, writing code meant typing the source code into a machine with a keyboard and then having the code printed on punch cards, which in return were then fed into the mainframe computer. But in the 1970s and 1980s, a more efficient way of writing code came about, and you could write source code, compile it, and feed the binaries directly into the computer for processing without the need for punch cards. It was a time when graphical user interfaces were not yet developed, but there were already tools to help you write code and check if what you wrote was okay. Text editors like VI, for instance. And then the code editor known as GNU Emacs. Emacs was in fact the first coding tool that I used when I started writing code. Emacs, like VI, ran on a command line, but it was highly configurable and so much more than a simple text editor. There were plugins and extensions that allowed you to do many things like compiling the program, and I believe also syntax checks through a static code analysis tool called lint. In a way, Emacs was an early version of an integrated development environment, or IDE. Emacs, by the way, is still around, as is VI, and there are quite a few enthusiastic user and developer groups who keep them going. Pure text editors, however, were gradually replaced with editors using graphical user interfaces. And it was Borland's Turbo Pascal that was a popular choice for this. And over the coming years, these IDEs have become more and more sophisticated, to a point where they have a range of tools now that help you write not only error-free code, but also better code. And here are some of the things IDEs can do for you now. Highlighting errors to avoid mistakes or highlighting warnings when your code could result in a problem when you run it. Code searching tools is another one which is useful if you want to look up how a particular API, class or function should be used. And also things we all take for granted now, like debugging, version control, and even the refactoring code. But one of the features many IDEs have had for some time now is something called code completion. Intelligent code completion, if you like. Let's say you want to use a function in your code, so you start writing the name of the function, and code completion suggests how you can finish it. And this would include the right number of arguments and data types. Doing a tap finishes the code without you having to write it all out yourself. Or let's say you want to create a new class or test class. Code completion tools can write a basic class with initializers, etc. for you without you having to do it all from scratch. Well, writing a skeleton for a new class or function is usually based on a bunch of class or function templates that IDEs have built in. But code completion and suggesting how you might finish writing a line of code is a little bit more interesting. It is based on the concept of prediction. That is, anticipating what you want to write once you start it. And even this form of syntax prediction isn't exactly new, and not exclusively used for coding either. Search engines have been using this technique as well for quite some time. In short, the ground for AI-assisted coding or language processing in general has already been laid. But it was, of course, the emergence of large language models, or LLMs, like ChatGPT that took it to another level, and not only for natural languages but also for programming computers. This breakthrough is rather recent as 2 years ago when ChatGPT astonished the world with remarkable results when running it. What happened next is what we all know, a frantic activity to create tools based on large language models. And that included tools like GitHub's Copilot that many of you will have heard of. I'm not sure if it was the first AI-assisted tool there was, but it's certainly one of the first ones, and a very successful one too. Well, perhaps not surprisingly, as many of us have repositories in GitHub, so it's quite tempting to use Copilot as well. Confusingly, there's another Copilot provided by Microsoft. Confusingly in two ways, because of the name, of course, but also because GitHub is actually a part of Microsoft. But in addition to GitHub's Copilot, there are others as well, like for instance one from a company called Hugging Face, which is using open source software tools and models. I included a link in the show notes where you can find more than a dozen of other AI code assisting tools. AI code assistants are trained on existing code in order to be able to create new code or do some code completion or suggestion, very much like large language models work on natural languages. And there is plenty of material out there to get a good training set for these LLMs. Just think of how many public repositories there are on GitHub alone. The last number I have is from 2023, when there were 420 million repos or so in total, and something like 28 million public repos. As I said, the rise of AI-assisted coding tools is rather recent, and because of that, there are a number of questions around it, some of which I will come back to later. But first, let's hand over to my guest Liam from Imperial College and see how he is using AI-assisted coding tools, and which ones. So here he is.
My name is Liam. I'm currently a teaching fellow at ECRI, that's short for Early Career Research Institute at Imperial College London. My background is computing. I deliver data science courses to master students and also PhD students at the Imperial College.
And you've been doing that since when?
Oh, I've been doing this since July 2020.
All right, okay, well,
Yeah.
during the pandemic then.
Yeah, during the pandemic time, yes.
And I believe that you're using AI, generative AI, to help you with coding and using that in classes as well. Is that correct?
Yes. I use in generative AI to help me to design some teaching materials, including mainly like hands-on practice for students. And also, I suggest students to seek some help from generative AI during their coding learning process. So that's how I involve into like a daily use of generative AI.
We're supposed to be talking about coding, but actually you're using it also to create teaching material and other bits as well.
Yes. So sometimes I want to have a kind of fairly good level of a challenge to my students when designing the coding practice. Using my own knowledge about coding practice, it could be sometimes like too advanced for students because, for example, my master students, they come from very different backgrounds. So most of them don't have any like a coding experience before they joining Imperial. So I need to have a kind of appropriate level of challenge to them. So I don't want to discourage them from learning coding. So I want to have a better integration of a level of fun and also a level of a challenge for the students when they get hands-on practice for coding. So I think generative AI has given me a great help regarding the design of the hands-on practice.
When we talk about generative AI for coding, could you tell us what kind of tools you're actually using? So the practical aspects. I know there's GitHub Copilot, but I believe there are now a number of other tools available as well. So which ones are you using?
For me, I'm using the Microsoft Copilot. Yeah, although they have the same name Copilot, but I think slightly different from GitHub Copilot. I use the Microsoft Copilot because this is the college has signed up a kind of like what you call it agreement with Microsoft.
Yeah.
And we use all the authorized packages from Microsoft, including the Copilot. I know Copilot is running GPT kernel at the background. And then also we got like unlimited use to the Copilot because the college has subscribed to the Copilot. So that's my main tools for the generative AIs. Sometimes I also use like a GPT another word people may know as a ChatGPT. I'm also another tool called Cloud, and also Google Gemini. Try to double check the coding material because I want to deliver something appropriately to students. I don't want to mislead the students. So I want to use multiple tools to guarantee the coding practice are correct properly.
So in practical terms, when I'm sitting in my
Yeah.
computer, let's say I'm
Yeah.
using Visual Studio Code. So how does this work? How do I integrate it? And how do I actually use it in practice?
If you use VS Code, Visual Studio Code, you can install extension like a GitHub Copilot, so which is also currently very popular generative AI tool for helping with coding. I also use that during my own coding practice when I use VS Code. So after installing the extension, then the GitHub Copilot will be activated. And of course, you need to log into your GitHub account to authorize the use of a Copilot in VS Code. And then that help the coding greatly by sometimes like giving the prompts or hint about what I'm going to do. That of course help me shorten my thinking time, and then I can complete the line of the code and then move on to the next step. And also, if I encounter any kind of error, I can immediately ask within the VS Code interface. Then I don't need to switch to like a web browser or the Copilot app to ask the error. So I think that kind of integration really facilitate the coding practice, and by giving lots of convenience and also help with the code design.
I try to get a picture for the listener how that works. So is it that I start writing some code and then make suggestions of how to complete it? Let's say I create a function in Python or a class in Python, and then it populates the rest. Or do I actually specify in a text window, say, hey, ChatGPT or hey, Copilot, give me a test case for class X? How does this work?
Oh, yeah, either way will work. So, for example, when I try to write a function to implement something, then at the beginning, I want to get an easier start. So then I can use the side pane in the VS Code. It has like a Copilot prompt I can type in. I say, I want such a function in
Yeah.
what language, for example, in Python, and then tell the GitHub Copilot a bit more detail about what I want. And then the compiler will immediately generate a sample code. Then I can copy paste into my Jupyter notebook in the VS Code and start testing the function. If I get any error, I immediately can copy the error message into the Copilot in prompt. It will try to analyze what's going on with that function. For example, you can immediately get a sample function to start with. And during the actual coding, for when you start writing a line, the Copilot will try to think about, oh yeah, what do you want to do in this line? For example, if like some easy task, for example, I want to load data from the current working directory. And when I start to write, like for example, in Panda and read the CSV, it will try to understand, yeah, that's when you want to load probably a CSV data set, and then it will try to overlook the possible data in the same folder, try to give you the file name of that data set, and then you can simply probably just select from pop-out menu or tab key to complete the line, so which make my like coding easier, because I then I don't need to look into what files I need, because the AI has already overlooked the list of the files I have.
We're talking about prompts, which is great, because I think there is something about the way that you write the prompts, that you write your query, if you like, into the prompt, that makes the responses a little bit more closer to what you want. And so what kind of tips can you give people then, or what kind of tips do you give students to say, this is how you get the best out of a prompt? The kind of prompt engineering, if you like.
Yeah, of course. This requires some experience about coding, and then when you write the prompt, you need
Mm,
to catch the keywords about what you want. Otherwise, generative AI can often misunderstand what you want and give you something you think, well, that's not what I want, something like that. So yeah, I have already talked to some students. They complain to me, say those AI tools are not great at all because they don't understand what I need. And then I show them, okay, we need to talk about how you try to manipulate, like
mm,
tricking the keywords you need to help the AI understand better about your need, and then the AI can give you the feedback more accurately. So, of
mhm.
course, it depends on the cases. So, but I would say try to elaborate your question as much as possible with more detail will be great because then AI will have better understanding about your needs.
Which might pose a problem for people who are beginning with coding, because as an experienced coder, you probably know what question to ask and you're very specific. But as a
Hmm.
beginner, you're probably not that specific because you don't know how
Yeah.
you go about it and what kind of question you should ask. So, how can beginners then get into
Mm.
that? Or is perhaps generative AI for coding more suited for the more experienced engineers?
So yeah, for example, if we want to
Mm,
process a data set, then we want to write a function. Given a trading data as an example, for like exchange trading data, if we collect online or whatever, we are looking to a time series data. We have like a trading date and even time, which is stock. And then every day, if we look into, for example, daily trading data, we have open price, low price, close price, and etc. So if we just tell the AI, for example, we want to calculate the daily
mm,
return value for a certain stock, if we just say that, because the AI cannot immediately see the
mm,
data, what data we have, it's very vague for AI to guess, okay, what actual values you want to base on to calculate the return values you are expecting. So then it's too vague for AI. So AI may not be given
mm,
accurate answer. But if we ask, when we give the prompt to AI, we say, okay, this is the data I have with some the columns. So tell the AI
mm,
detail about what data are included in your data set, and then what I want and what's the equation I would like to use to calculate the daily returns for which stock. And then because this detail given to AI, including the columns of the data, the equations
mm,
used for calculation, and then AI can give an accurate answer, like for example the sample code. That's what
mm.
I notice when some students as a beginner for programming, they thought blindly AI should know everything by sort of mind reading. So they just ask the AI what they want, but they didn't tell AI a bit more detail
Mhm.
about what data they have. That's my suggestion. If you want to get more accurate answer, you should give the detail as much as possible, including what data you are having at the moment, and then by even giving more detail, like what columns in the data, you should describe a bit more detail.
How effective is generative AI then in coding, would you say? At what stage in the coding process does it help? Is it helping throughout the entire process from start to finish, or are there particular areas like coming up with a new application, doing the kind of boilerplate stuff, or can it actually help you throughout the entire development cycle?
Question is quite hard to give a
Yeah.
kind of unified answer because it's yes and no. For example, if the question are fairly simple, like for the beginner level, AIs are quite effective to implement those tasks in by a few communications. If the questions can be quite complex and also there are not many resources available even on the online resource, then AI also struggle to help too. So giving that example, if we go back to the earlier example,
Mm,
like trading data, to calculate like daily return values for a stock or multiple stocks, there are lots of examples available online. So AI tools have those knowledge how to implement the calculation encoding in different programming languages. So in that sense, AIs are very effective. But recently, for example, I would like to use VS Code together with another environment quartal to code R, and then I want the quartal to render R notebook or another word called R Markdown into a PDF file with nice table of contents, including like list of figures and tables. Use the traditional way in RStudio. It was fairly easy to do that. However, I think Quartal is fairly new tool, and then there are not many examples available. I use different AI tools try to help me out to implement the list of tables and figures when rendering to PDF, but they are still AI still struggling to give me a very effective sample code. I couldn't work it out so far at the moment, and then I keep feedback to the AI about what errors or what kind of output I get, but they insist with the limited knowledge they have at the moment. It telling me what to do, but never work out at the moment.
We're coming to the end now, but the quintessence really is that it's not going to replace developers and engineers at any time soon. So you still need to spend some time making corrections, but there are cases when it really can help.
Yeah. Software developers and programmers, at least, don't need to worry being replaced by AI at the moment, because AI still have limited capacity to do things.
As Liam said, we shouldn't get overly nervous in being replaced by a bot. For now. The emphasis at the moment seems to be on helping to write code, or at least to get started. Typical scenarios and use cases that I heard people use with AI tools are writing test cases and unit tests, getting started with a new application or new code fragments without having to write a lot of boilerplate code, refactoring code, that is improving existing code without changing its functionality, and getting ideas for how to write a particular function or code segment. That's of course not an exhaustive list, and if you're using these tools, you may well use them for different purposes. But whatever comes out of the tool, and what everybody agrees on, including Liam as you just heard, is that it needs to be checked. And rare is the case where what you get out of the AI-assisted coding tool is something you can take as is. AI-assisted coding tools give you a starting point, but not the finished product. The other thing we learned from Liam is how you use AI code assistants, something that has been given the name of prompt engineering. As Liam said, the more specific you are in your query or prompt, the closer the result will be to what you expect. The OpenAI webpage has a whole page dedicated to prompt engineering, and you can take a look at it following the link in the show notes. What I find interesting about this is, and this takes me back to the short clip from the TV series Star Trek, that I could imagine how giving prompts may also turn into a future meta-programming language in its own right. Maybe that sounds a little bit outlandish at the moment, but after all, the way we program computers has changed a lot since the early days. From hardwiring programs, to human-readable assembler code, to more abstract and sophisticated languages that are even more readable. So, who knows? Maybe we will be dictating prompts to design and create a program in future. But back to the here and now. Despite all the promises AI tools for coding make, there are some questions around how useful they really are, in their current form that is, for different types of programmers and programs. Take for instance programming languages. When you go to Stack Overflow's survey from 2024, you'll discover that Java and TypeScript, along with Python, are in the top 5 most widely used programming languages. Well, no surprise there then, is there? But in fields like high-performance computing, on the other hand, other languages are often used as well. like C++, which is quite a bit further down the list in terms of usage, or take, for instance, Fortran, in particular modern Fortran or Julia, languages that rank pretty low in terms of how many people use them. Why does this matter? Well, let's remember that LLMs are trained on datasets, and the more samples you have, the better the result and the better the prediction. As a result, LLMs may be better trained on the more popular languages than with the less used ones. Well, I haven't tested this, so I cannot tell you whether the quality of results for AI-assisted tools is really different for, say, Python or Fortran, but I think it's an interesting question to ask and look into. Another point is who it's for. Liam is using AI-assisted coding tools with people who are relatively new to software engineering, and I would imagine that AI tools could be put to good use in this case. But would it be the same for experienced and more senior engineers, though? Again, I do not know, but again, I think it's worth considering. One thing seems to be clear. Developers have embraced AI coding tools and are exploring them and seem to be positive about it. Allow me to go back to the Stack Overflow survey results from 2024 I mentioned earlier. Around 80% of the developers who responded to it think they improve productivity. Over 80% of the respondents use them to write code. And they also think that they will be more deeply integrated in documentation tools and writing code and tests in the future. But they don't seem to go blindly into this, because over 40% of respondents think that AI tools don't handle the more complex tasks very well or not well enough. And they are split over the question how good or accurate the results are. Well, I guess the best way to answer all of these open questions about AI-assisted coding is to test it yourself. There are tools aplenty. However, I should add that they usually do not come for free, so it's probably best to check whether the institution, university, college, research center, or whatever organization you're based at has an agreed license and contract with one of the providers that offer AI tools, and then start with that. In the meantime, I hope we won't all get lost in the current hype around AI. I guess it will wear off after a while, as hypes usually do. Still, it's difficult to escape it, isn't it? And if all the predictions and promises of AI will come to fruition, well, I hope we won't be ending up like the character Cypher in the science fiction movie The Matrix.
I know what you're thinking, because right now I'm thinking the same thing. Actually, I've been thinking it ever since I got here. Why, oh why, didn't I take the blue pill?
Anyway, enough of science fiction movies now, and we've reached the end of the episode anyway. And as I said in the beginning, this is the last ByteSized RSE episode in the Code for Thought podcast, and because of that, there won't be a quiz this time. I do hope that you enjoyed the episodes from the 3 seasons. And I'd like to take the opportunity to thank all the people involved in the project and who supported the sessions and this podcast. In particular, Steve Crouch from Southampton University, Jeremy Cohn from Imperial College in London, and of course Neil Chu Hong from the Software Sustainability Institute, who all got the ball rolling. I also like to thank Irini Sompa, who organized the online sessions for this season. And of course all the many people I had the pleasure of meeting and talking to on this podcast. And finally, the clips from Star Trek and The Matrix are available on YouTube, and you'll find the links in the show notes. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.